Hi guys, today we'll be solving minimum number of jumps. So let's try and understand the question. Given an array of n integers array where each element represents the maximum length of the jump that can be made forward from that element. This means that if array of I is x, then we can jump any distance y such that y is less than x. Find the minimum number of jumps to reach the end of the array, starting from the first element. If the element is 0, then you cannot move through that element. Return -1 if you cannot reach the end of the array. Let's try and understand this question. So we are given an input n, which is 11 numbers, and array is given and the output is 3. It means that if we select the number of jumps properly, we'll be able to make it to the last element of the array in just 3 jumps. Let us try to see how. So we'll start from the first element and we can make a maximum of 1 jump from here. So we go to the first position and we see there's a 3. Now from here we can make 3 jumps, at max 3 jumps. It means that we can make less number of jumps if we decide to do so. So we see for the next 3 jumps, for the next 3 elements, what is the maximum? We see it's 9 at the third jump. So we select to jump a maximum distance of 3 and we see it's 9. From 9 from here we can jump a maximum distance of 9, and that will be more than the index 11. So we can easily reach the end of the element by jumping less. Let's try and understand how to solve this. So we have the array here. Let's see its index. So what we can do is we can keep three variables. One to keep the count of step, one to keep the maximum reach, and one to keep the count of the thing that we have to return, that is the number of jump. Initially we'll initialize it to the first element of the array because that is what we can do, that is what we are instructed to do. And we'll do the same thing for maximum number of steps. Initially we can only take the number of steps that is at position 0. And jump, initially we'll keep the jump count as 1 because we'll need at least 1 jump to do it. We'll look at the edge cases soon. So we'll start from the first element and we'll see. So the max reach currently is 1 and we can make, so we have 1 step and the max reach is also 1. So we can reach to index number 1 from here, and the maximum number of steps that we have currently is 1. So we'll go here. Now we check what is the max reach. So now we are at index 1 and it has a jump value of 3. So from 1 we can jump 3 values or a distance 3. So the max reach will be updated to current index plus the value at the current index. In this case it's 4. So we can jump a maximum of 4. And the number of steps, because we did a jump 1, so we need to decrement it to 0 now. So we check if the number of steps is 0, we update the new value to max reach minus the current index. Max reach is 4, the current index is 1, so it will be 3. So now we can make a maximum of 3 jump, a maximum distance of 3. So let's try to find out the maximum reach by traversing the entire array, by traversing the entire length of maximum distance. So we go here and the max reach would be 2 plus the value at index 2, that will be 7, so we'll get updated. We move forward. At index 3 we have value 8, so it will be 3 plus 8, that will be 11, so we'll update it. We reach at index 4. Okay, so each time we are moving forward, we need to decrement the number of steps as well. So we move 2 times, so it will become 1. And here we see at index 4 the value is 9, so we can reach a maximum of 13. So we'll update the number of steps as well. It becomes 0, and as soon as the value becomes 0, we need to update the jump count as well. So we update it, so it became 0 2 times, so we need to update it. Became 2 and then became 3. So now the max reach is, so the new number of steps will be, max reach is 13, so 13 minus the current index, that is 4, that comes out to be 9. So we can take a maximum distance of 9 we can jump. So let's try and keep continuing the count. So the jump currently is 3, so we'll keep moving forward. So we reach here 5 plus at index 5, the value is 2, 7, the max reach is 13, so we are not going to update it. We'll reduce the count, it becomes 8. We'll keep moving forward. At 6, index 6, the value is 6, so we can reach a maximum of 12, but the value is already 13, so we'll not do it. We'll reduce the count, then we'll move forward. At 7, the value is 7, so we'll update it because it is more than 13, max reach now. Then we'll move forward. At index 8, the value is 6, so 6 plus 8 is 14, the current value is 14, so we'll not update it. At index 9, the value is, so let's move forward. At index 9, the value is 8, so it becomes 17. We'll update the max reach, it becomes 17. We'll move forward. So we reach the end of the array. Max reach will be 10 plus 9, that is 19. We update it. We also update the number of steps, so it is 4. And we see that we have reached the end of the array and the number of jumps is just 3. So what we can do is we can just return 3. Let's try and code this. So what we'll be doing is we'll also try to cover the edge cases. There could be a case where there is only one element. In that case, we are already at the end of the array, so we'll just return 0. There could be a case where the first element itself is 0. In such a case, we cannot make any moves, so we'll just return -1 as it was instructed in the question itself. If those two cases are not true, then we can look forward for making the next code. So as we discussed earlier, initially we can only reach the first element, so we'll just keep the max reach to first element's value and the number of steps will be the same. Initially we'll be only able to move the number of steps which is the value at initially array of 0. So the first two conditions here have failed. It means that we'll require at least one jump to complete the question. So we'll initialize the number of jumps to 1. Then we'll traverse the entire array once. We'll start with the first element because we have already seen the element at 0. We'll keep incrementing. We'll check if we reach the final element, we'll just return number of jumps. If not, we'll continue. We'll update the max reach such that the max reach is maximum of the previous max reach and the maximum of the sum of the current element and the value at the current position. Suppose we are standing at index 5 and the value at index 5 is 10. So the max reach will be 5 plus 10, 15. Therefore, I think you can understand the logic here. And each time we are moving one step forward, we need to reduce the number of steps that we have taken. If the number of steps becomes 0, we need to check a few more things. Firstly, we need to increment the number of jumps because as soon as the number of steps becomes 0, we need to jump because we cannot take any more step to check whether there's a better option out there. If I is greater than or equal to max reach, it means that we cannot reach the final element and we'll return -1. And then we'll update, and if that case is not true, we'll just update the number of steps. And if after traversing the entire array we cannot reach the last element, we'll just return -1 because it's not possible. Let's try and run this code. So there's a typo here. So as we see that this code is successfully submitted and passed all the test cases. So if you like this video, do share and subscribe.